Hello, welcome back to Practice Problem 7, Week 10, Fall 2021, Intro to ECE. I'm Dr. Roberts, and for Practice Problem 7, we're going to analyze this amplifier circuit, ideal op-amp circuit, where we have the input is connected to the inverting input, and there are two resistors in parallel in the feedback here. And if you just work Practice Problem 6, you'll see this looks very, very similar to when we just worked, and we worked the gain out. And one thing you should notice very quickly in this problem is these two resistors are just in parallel. So you could write them as an equivalent resistance to simplify the circuit, right? So what if we do that, right? So now let's do that first. So we say, okay, well, I can do this, or I can just say, okay, if I go this way, I get, let's redraw my little circuit here, R1, V in. Practice lots of drawing and sketching and electrical engineering. Actually, we have V out, and there's a single resistor where now the value of this, these are in parallel, so that's R2 parallel R3. But now if I look at this circuit and compare it to, again, practice problem 6, I have the exact same circuit I had in practice problem 6, where instead of the resistor having this resistor having a value of R2, it now has some new value R2 parallel R3. Right? So, if we then work it, we'll find we will get the exact same gain relationship, but R2 here will be replaced with R2 parallel R3, right? So let's do it, and we'll see that I'm right, and that the math works, and that physics is our friend, right? So always, as we know then, right, we know that Vn is equal to Vp, and In is equal to 0, and Ip is equal to 0. So if we look here, we have, at this point, ground. So we have ground, 0 volts is equal to Vp. That's equal to Vn, which is equal to Va. So we see that Va is equal to 0 volts, right? So this is ground here. We can now do KCL at this node. We've been doing this, right? So at A, and we can draw some currents. We can just make it up. It doesn't matter which way you go as long as you're consistent. So we get, right? So we get that says that I1 plus I2 minus, we can, just for completeness, write In there. It's equal to 0. This is 0 by definition. So again, just like last time, it's the exact same problem. Our KCL says I1 is equal to negative I2. Now, using Ohm's law, again, we can do the exact same thing we did in the previous problem. So I1 is going to be equal to V top minus V bottom. So that'll be equal to Vn minus Va over R1. And Va0, that's going to be equal to Vn over R1. And again, I2, that's going to be equal to V out minus Va over this resistor now, which is R2 parallel R3, right? And VA is equal to 0, so that's equal to V out over R2 parallel R3. And now we can just substitute in, right? So I1 is equal to V in over R1 minus I2, so minus, then I2 is equal to V out over R2 parallel R3. And if you do that, we see this, and we can go and we can rearrange. And if we do that, we get that V out over V in is equal to minus R2 parallel R3 over R1. Which, if you go back to the previous problem, is exactly the same, where again, instead of R2, you now get R2 parallel R3. Now, that being said, this may not be convenient for actually plugging and chugging, so what can we do here, right? If you recall, for two parallel resistors, what we can do here is we can replace this with the equation, right? It's equal to R2 times R3 over R2 plus R3, right? And so now if we move things around, we can rearrange this. So if we look at, so if we see that V out over V in is equal to minus R2 parallel R3 over R1, we can rewrite this as negative 1 over R1 times R2 parallel R3. And now we can substitute in here, and we see that V out over V in is equal to minus 1 over R1 of R2 R3 over R2 plus R3. Now, so this gives us a full value here. We can now plug these things in, right? So, and this is true if we had any two resistors here of any value, complex value, that here would be then the relationship. So now we can plug in our resistor values in part 3, 2 kilo ohms, 12 kilo ohms, and 6 kilo ohms. And we see in that case, we get that V out over V in is equal to minus 1 over R1, which is 2 kilo ohms, times R2 is 12 kilo ohms, times R3 is 6 kilo ohms, divided by 12 kilo ohms plus 6 kilo ohms. Right? And if we plug all those numbers in, that works out. This whole thing becomes 4 kilo ohms there. So that is equal to minus 4 kilo ohms divided by 2 kilo ohms, which is equal to minus 2 is our gain in this case. So the same thing works out even if we had multiple resistors, right? Or multiple elements here. And what we'll see in the next problem is, well, what happened if we make one of these a capacitors, right? Where again, if you go in the phasor domain, we will treat, once you've converted a capacitor in the phasor domain, you treat it like a resistor. So you will arrive at the exact same equation here, where instead of having a value for the resistor, you'd have 1 over j omega c. And we will see that in the next problem, and I will see you there.